In this video, we want to learn how we can use double integrals for finding volumes. Find the volume that lies under the plane 4x plus 6y minus 2z plus 15 equals 0 and is above this rectangle. X is between -1 and 2 and y is between -1 and 1. So here we want to find the volume of the solid that lies below this plane. You can see the plane here and is above the rectangle. The rectangle is x between -1 and 2 and y from -1 and 1. So this is the rectangle that you can see here, below the plane and above this rectangle. So we want to find the volume of this solid. Attention that we don't need to have the graph of the plane and the rectangle, but it's good to have an idea about what we are calculating. So let's start. As you know, when we want to find the volume under any surface, first we have to find usually the given equation for z, because we want to have equation in the form of z equals f of x and y. So the first thing here we have to do is to solve this given equation for z. From this equation, if we want to solve this for z, we can move 2z to the other side, and then we have 2z equals 4x plus 6y plus 15. If we divide both sides by 2, z equals 2x plus 3y plus 15 over 2. Now for finding volume, we have double integral of 2x plus 3y plus 15 over 2 dx over dy or dy dx. The order of integration here really doesn't matter, because this function is very simple function, and so integrating should be easy. Let's suppose we write first dy, then dx, then dy. Dx times dy. X changes from -1 to 2 and y is between -1 and 1. First we have to integrate this function with respect to x. So we have integral from -1 to 1. Integral of 2x with respect to x is x to the 2. Integral of 3y is 3yx. Attention, when you integrate with respect to x, this is like a constant. So integral of 3y is 3yx. And integral of 15 over 2 with respect to x is 15 over 2x. And x is from -1 to 2 dy. Now we have to plug in 2 for x and then -1 for x, and we have to simplify this. So we have integral from -1 to 1. If we plug in 2 to the 2 is 4. Then we have 3y times 2, which is 6y, plus 15 over 2 times 2 is 15, minus, now we have to plug in -1. If you plug in -1 for x, we have -1 to the 2 is 1. So 1 plus 3y times -1 is -3y minus 3y. And if you plug in -1 here, this is -15 over 2 dy. Now we have to simplify this expression. We have 4 plus 6y plus 15 minus 1 plus 3y plus 15 over 2. 4 plus 15 is 19. 19 minus 1 is 18. 18 plus 15 over 2 is, if we do a common denominator, 18 is 36 over 2. 36 over 2 plus 15 over 2 in total is 51 over 2. So this equals 51 over 2 plus 6y plus 3y is 9y. So 51 over 2 plus 9y is this expression in the bracket. So we have now integral from -1 to 1 of 51 over 2 plus 9y dy. Now for finding the integral with respect to y, integral of 51 over 2 with respect to y is 51 over 2y, and integral of 9y is 9y to the 2 over 2, and all of this is from -1 to 1. Now we have to plug in 1, and we have to plug in -1, and we have to subtract. If we plug in 1 here, we have 51 over 2. And if we plug in 1 here, we have 9 over 2. All of this minus. Now we have to plug in -1. Then we have minus 51 over 2. And if we plug in -1 here is 9 over 2. 51 over 2 plus, attention, minus times minus is plus. 51 over 2 plus 51 over 2 in total is 51. And if your attention, we have 9 over 2 minus 9 over 2 is 0. So the answer is 51. So the volume of the solid that lies below this plane and is above this rectangle, the volume of this solid is 51. Now let me show you another example. Find the volume that lies under z equals x to the 2 plus xy to the 2 and is bounded by z equals 0, x equals 0, x equals 5, and y is 2 and -2. Here you can see the graph of this surface. This is the graph of the surface, which you can see here. And this rectangular region, which is x0, x5, as you can see, x is changing from 0 to 5, here is 5, and y is between -2 to 2. Here this point is y -2 and this point is 2. So this is the rectangular region that you can see. So we want to find the volume of the solid that lies below this surface and is above this rectangle. So we want to find the volume that lies below the surface above this rectangle. I hope you can imagine the volume that we want to find. But again, it doesn't really matter that you know the graph of this surface. The thing that matters is that you have to be able to write properly the double integral, and then you have to be able to find the value of the double integral. Here the volume is double integral of the surface x2 plus xy to the 2 dy dx. If you want, you can write dx dy. Really, the order of integration in this example also doesn't matter, because the integration of this simple function is not hard at all. As you can see, x is from 0 to 5 and y is between -2 and 2. Now we have to find the integral of the function first with respect to y. So focus on this part. We want to find integral of this expression with respect to y. Because we want to find integral with respect to y, this is like a constant, and so integral of x to the 2 is x to the 2y. So we have integral 0 to 5 of x to y, and integral of xy to the 2 is, x is a coefficient, we leave the coefficient, integral of y to the 2 is y to the 3 over 3. All of this is from -2 to 2 dx. Now we have to plug in 2 and -2, and we have to subtract. we have integral 0 to 5. If we plug in 2, we have 2x to the 2. If we plug in 2 here, 2 to the 3 is 8, 8 over 3 times x. Minus, now we have to plug in negative 2 for y. We have negative 2x2. And if we plug in negative 2 here, we have negative 8 over 3x minus 8 over 3x. And all of this in a bracket dx. 2x to the 2 plus 2x to the minus times minus is plus. Is 4x to the 2. So this equals integral 0 to 2 of 4x to the 2. 8 over 3x plus 8 over 3x is 16 over 3x. So we have 16 over 3x dx. Integral of 4x to the 2 is 4/3 x to the 3 based on the power rule, and integral of 16 over 3x is 16 over 3 times x2 over 2. The 2 with 16 cancels, this becomes 8, so the integral is 8 over 3 x to the 2. All of this is from 0 to 5. If we plug in 5 here, 5 to the 3 is 125. 125 times 5 is 500 over 3. 5 to the 2, 25 times 8 is 200 divided by 3. If we add these two, it's 700 over 3. So the volume is 700 over 3. Find the volume that is bounded by this surface. Z equals 1 plus x2 y e to the y, and the plane z equals 0. Attention, z equals 0 is the xy plane, so we want to find the volume of the solid that is below this surface, above the xy plane, and x is between negative 3 and 3, and y is from 0 to 1. Immediately we can write the double integral for this volume. Volume equals double integral of the function 1 plus x2 y e to the y. Here we can take integral with respect to x, then with respect to y. And because, if you attention, this function is easier if we want to integrate first with respect to x. So it can be a good idea to take integral with respect to x first, then with respect to y. But if you want, you can integrate with respect to y first, then with respect to x. X is from negative 3 to 3. Y is from 0 to 1. Attention, for integrating with respect to y, because of this part, y times e to the y, we have to integrate this part by integration by parts method, but we want to first integrate with respect to x. Integral of 1 is x, and integral of x to the 2 is x to the 3 over 3 y e to the y. All of this is from negative 3 to 3 dy. Now we have to plug in 3 for x and negative 3, and we have to subtract these from each other. Now if we plug in 3 for x, we have 3 plus 3 to the 3 is 27. 27 divided by 3 is 9, so 9y e to the y minus, if we plug in negative 3, we have negative 3. Negative 3 to the 3 is negative 27, divided by 3 is negative 9, y e to the y dy. And all of this should be in the bracket. 3 plus 3 is 6. So we have integral from 0 to 1 of 6. 9y e to the y. Minus minus is plus. Plus 9y e to the y is 18. y e to the y dy. Now we have to find integral of this expression with respect to y. Integral of 6 is 6y, and integral of y e to the y with respect to y with the integration by parts method would be y minus 1 e to the y. I will explain how we can find the integral of this expression with respect to y after I finish my calculation here. For now, suppose that you know how to calculate this integral. After I finish my calculation here, I will show you how you can integrate y e to the y dy with respect to y with integration by parts. So this is the integral of this expression. All of this should be from 0 to 1. If we plug in 1 for y, we have 6 times 1, 6 plus. If we plug in 1 here, all of this is 0. 1 minus 1 is 0, so we have plus 0. Minus, now we have to plug in 0. If we plug in 0 here, 6 times 0 is 0. And if we plug in 0 in this term, we have 18 times negative 1 times e to the 0, which is negative 18. Attention that when we plug in 0 here and here, e to the 0 is 1. 0 minus 1 is negative 1 times 18 is negative 8. If we simplify this, this equals 24. So the volume that lies below this surface and is above this rectangle, the volume of this solid is 24. Now let me explain how we can find the integral of y e to the y dy with the integration by parts method. If you remember, in the integration by parts method, we suppose part of this expression, part of the function u, and the other part dv. And usually we suppose u, the part that its derivative is easier. Here we suppose y, as u, and we suppose e to the y dy as dv. From dv we have to integrate, then the v with integrating from both sides is e to the y. From this, if we find differential of your du equals dy. So if you remember, in the integration by parts, we suppose part of this function as u, and that part is usually the part that its derivative is easier. Derivative of y is 1, so it's easier function. So for this reason, it's a good idea to choose y as u. Now let me remind you the integration by parts formula. Integral of u dv is uv minus integral of v du. Based on this formula, the answer of this integral equals uv, u is y, and v is e to the y. So y e to the y minus integral of v, which is e to the y, du, du is dy. Now we have to find the integral of e to the y. So we have y e to the y minus integral of e to the y is again e to the y. And of course we have to write the constant at the end. But if you pay attention, you can write this answer in the form of y minus 1 e to the y. And this is exactly the expression that I wrote for integral of y e to the y minus 1 e to the y. It is exactly same expression. But there is easier way for finding simple integrals like this. You can find this integral with integration by parts with the table method. let me remind you the table method for finding the integral of this function. We draw something like this. We draw something like a table. It has two columns. One column is derivative, the other column is integral. And here we always put plus, minus, plus, and so on. In the derivative part, we put y, and we take derivative of y. Derivative of y is 1, derivative of 1 is 0. And in the integral part, we put the other function, other part, e to the y. Integral of e to the y is e to the y, and integral of e to the y again is e to the y. Now, based on the table method, the answer of this integral is simply this times by this. You have to multiply the first part, the first element from the first column, by the second element. So the integral is y e to the y. Then, attention, here if you have a minus, so minus 1 times by this minus e to the y. And because here is 0, we do not continue, and that's it. So as you can see, the table method is basically the integration by parts method, but instead of choosing u and dv, we just make a table, and we are finding the integral in this way a little faster. If you want to learn more about integration by parts with the table method, you can watch my video for this topic. Now look at this example. Find the volume that is in the first octant bounded by the cylinder z equals 9 minus x to the 2 and the plane y equals 4. So we want to find the volume of the solid that is below this surface, which you can see this surface here, that is in the first octant. Attention, in the first octant. First octant is x positive, y positive, z positive. It's like first quadrant, but the first octant is the octant that x, y, and z are all positive. So we want to find the volume that lies below this surface that we can see here, and in the first octant. Please attention, this is the first octant. So in this region, which x is positive, as you can see, x is changing from this point to this point, but we have to find this point, and y is from 0 to 4. This point is 4. So let us start. But before finding the volume with the integral, first we have to find this value of x, that this surface crosses the xy plane. For finding this point, basically here, for finding this, simply we have to set z equal 0. When we set z equal 0, we are finding the intersection of the surface, this surface, with the xy plane. And we want to find basically this line, or you can say this point. So in this equation, by setting z equals 0, we have 9 minus x2 equals 0. And from this, we have two values, plus minus 3. But the minus 3 is here. But because we have limited ourselves to the first octant, so we only accept positive 3. Now you should be able to write the double integral. For finding the volume, volume would be the double integral of the function 9 minus x to the 2. We can write dx dy or dy dx. The order really doesn't matter because it's very simple. X is changing from 0 to 3. 0 because we are limited to the first octant, to the 3, 0 to the 3, 0 to 3. And y is from 0 to 4. This point is 4 for y. And y is from 0 to 4. For finding this integral with respect to x, Integral of 9 is 9x. Integral of x2 is x to the 3 over 3. All of this from 0 to 3 dy. If we plug in 3, 9 times 3 is 27. 3 to the 3 is 27. Divided by 3 is 9. 27 minus 9 is 18. So we have, when we substitute 3 for x, we have 18. So this equals integral 0 to 4 of 18 minus. If we plug in 0 for x, this is 0. So we have only 18 minus 0 or 18 dy. Integral of 18 dy is 18y from 0 to 4. If we plug in 4, 18 times 4 is 72. So the volume of the solid between this surface and over this rectangle, this volume is 72. I hope by watching this video you have learned how to find the volume of the solids over rectangular regions. If you like this video, please subscribe to my channel and see you in the next videos.